Hi, we're back talking about volume, length times width times height. It's kind of the next step up from area. An aquarium holding African cichlids is 7 inches higher than it is wide. Its length is 31 inches and its volume is 8,060 cubic inches. Volume is always given in cubic units of some kind. Okay, so here I went ahead and I drew a picture of this situation. Here's the aquarium. This is the width, this is the height, and this is the length. And since volume of a rectangular solid, or an aquarium, equals length times width times height, we know that the volume is 80/60, the length is 31, the width is W, and the height is W plus 7. I am ready to start working on this problem. And it just so happens that we're very lucky because 31 goes evenly into 80/60. So I'm going to divide both sides of this equation by 31 so that we can make the numbers a little bit smaller. Now let's double check. 80/60 divided by 31, enter. Okay, 260. So 260 is going to equal W times W plus 7. I distribute the W, so I'll have 260 equals W squared plus 7W. This is a quadratic equation. The highest power is 2, so I'm going to subtract 260 over to the other side so that I can set my quadratic equation equal to 0. Okay, now we just have to figure out how to factor 260, or negative 260 really, in order to get two factors that add up to 7, which is our B number. So I go here, and I clear, and I clear, and I go back up to Y1, and I say negative 260 divided by x, and then down to Y2 we'll have x plus negative 260 divided by x. Second graph, and what am I looking for? I'm looking for 7 in the Y2 column. So let's go up, because it looks like the numbers get smaller as you go up, and there's 7 right there. So the two numbers that we are going to use are negative 13 and positive 20. So 0 equals W minus 13 times W plus 20. That looks kind of like a 15. Better be careful there. This is a 13. Okay, I am going to set each factor equal to 0. Solve each of these little equations. I'll have W equals 13, W equals negative 20. Again, there is no such thing in our number system, in our reality, as a negative dimension. So I'm going to mark that out and go with W equals 13. So my three dimensions are going to be W equals 13. The height is 13 plus 7, which is 20. And we were already given the length, which is 31. So now, the height is 20, and the width is 13. Fantastic. Okay, now we have problem number 15. A square poster has sides measuring 2 feet less than the sides of a square sign. Let's read that again. A square poster has sides measuring 2 feet less than the sides of a square sign. So we're comparing a square sign to a square poster. If the difference between the areas, in other words, you're going to subtract the areas, if the difference between the areas is 28 square feet, find the length of the sides of the poster and the sign. So as near as I could, I drew a square a square sign and a square poster. Notice the sign is bigger than the poster. Each of the sides of the sign is 2 feet longer than each of the sides of the poster. Or, viewed the other way, the way the problem is worded, each side of the poster is 2 feet less than each side of the sign. The area of the sign is going to be length times width, x times x, which is x squared. The area of the poster is going to be x minus 2 times x minus 2, length times width. That will give me x minus 2 squared. And the problem says, if the difference between the two areas is 28, then I have to find the length of the sides of the poster and the sign. So here we go. Here is the bigger area minus the smaller area, and that difference is 28. Now, I'm going to work this problem. I'll have x squared minus x minus 2 times x minus 2 equals 28. So x squared minus, parentheses, x squared minus 2x is minus 4x. Negative 2 times negative 2 is positive 4 equals 28. Now, when I distribute the minus sign, which acts like a negative 1, I'll get x squared minus x squared plus 4x minus 4, and that equals 28. Now notice that the x squares have zeroed out. X squared minus x squared is 0, so I'm left with 4x minus 4 equals 28. The highest power of this equation is 1. It's linear, so I don't have to follow the zero principle that says I drag everything over to one side and set it equal to 0. So instead, I'm just going to solve this like a normal equation, add 4 to both sides. I'll get 4x equals 32, and divide by 4, x will equal 8. So, the length of the sides of the poster, each one of these is 8. A square always is the same measure on each side. Okay? So x is 8, and over here 8 minus 2 is going to equal 6. So the sign is 8 feet on a side, and the poster is 6 feet on a side. Good. Ah, we're getting to the Pythagorean theorem now, so I'm going to close this down and we'll start fresh.